You know, the weather is a little bit like a river. It has a beginning, sometimes just a little flow. It gathers momentum. It's got a few rough patches like storms and depressions. It has calm spots like the still pools in a river. And it has an end. Weather systems peter out, just like the river reaching the sea. And then the cycle begins all over again. Evaporation out of the oceans, condensation as the clouds form, and precipitation as the rain falls out of those clouds into the hills. Our little stream begins its life all over again. Now, location and topography, that's the shape of the land, means that we don't have constant climate in New Zealand. In fact, we get all types of weather, much of it packaged into tiny local identities we call microclimates. Now, as we've already seen, the prevailing wind is from the west, out there, straight off the Tasman Sea, and that's a key factor in the sort of weather we get. And nowhere is that more clearly demonstrated than on the west coast. The highest recorded daily rainfall is 682 millimetres at Collier's Creek in the hills above Hokitika, where the mean annual average is more than 6,000 millimetres. That's over 6 metres. Now, by contrast, in Manawatu, Otago and Southland, daily totals of more than 80 millimetres are very rare. So why is it so wet on the west coast? Before we answer that, have you ever thought about how rain forms? Sure, like snow or hail, it comes out of cloud. But it all begins with the old evaporation, condensation, precipitation formula. Let me demonstrate. Electric jug, you've all got one of those. Full of water, turn it on. If you pass heat over or through water, you get evaporation. Now, if we lift it to a cooler level, got an oven tray up here, you may have one of those as well. Let's get a bit of stuff out of the fridge. Organic diced carrots and put those up here. So this is our cooler level. Okay, so this is where the cloud, if you like, the condensation, the cloud development will take place. You watch. Now you see what's happening here. Of course, we're boiling the jug. Already we're seeing little tiny wee droplets, like cloud particles, forming on the bottom of our cooler layer. If you like, you can imagine a cooler layer of air. Here, of course, we're using our frozen peas and stuff to get that coolness. So the condensation beads are developing quite quickly. If we keep the lifting, the cooling and the condensation going, those tiny weedy water droplets, like cloud particles, stick together, grow and fall as precipitation, rain. Now, a similar thing happens here as the humid westerlies off the Tasman Sea hit the Alps. The air laden with water vapour is forced up, cools and expands and causes the vapour to condense into tiny droplets or cloud particles. With more lifting, cooling and condensing, droplets grow, join together and heavy rain falls. At the same time, the sun's energy, which evaporated the water in the first place, is now released as latent heat. Now, once all that rain has fallen over there, there's very little left for over here. What was a wet wind over there becomes a dry wind over there for the Canterbury Plains. Remember that latent heat was released as the rain fell? Well, as that dry wind descends on the lee or the eastern side, it becomes compressed and warms up as it moves into higher pressure. It becomes the hot, dry Fern Norwester. It's a strange one, this, and it becomes even more complex as we head down over there. Here in Christchurch, there's a weather phenomenon, a strange, spooky wind that seems to affect people. It's called the Norwester. Similar winds are experienced in Switzerland, Israel and Los Angeles. It's a hot, dry wind from the northwest. But why does it affect people? Well, here's a man who's got the answers. Neil, question. How does a wind that begins as a moist, cool one traverse a mountain range and arrive in Christchurch as a hot, dry one? How does it go through that metamorphosis?
Well, it actually is the sun shining on the Tasman Sea evaporates the moisture. So solar energy is converted into evaporated moisture.
Yep.
It hits the mountains, gets forced up over the mountains and rains, and that solar energy is released into the air again. So the air that comes over the mountains, as it comes down the other side, the pressure increases, it compresses it again, but it's warmer than it was before. And because it's rained on the west coast, it's drier. So we have warmer, dry air. It's very turbulent air, and it whips across the plains at quite high speeds. And static electricity builds up.
Yep.
And so a lot of people notice they get shocks when they open their cars and things like that, because the air is charged, it's getting onto your body, and it builds up the charge on you and goes back to your car. But we found that that was the mechanism for causing health effects.
Examples of errant behaviour. Have you got some examples?
Well, teachers say kids can't be controlled in classrooms. They just get so excited and...
Hyperactive.
Oh, very, very hyperactive. But of course, it's the teachers also who are feeling irritable and can't concentrate. So over day and night, the symptoms build up. So some people notice the symptoms very quickly. But by the third day of a Norwester, typically 60, 70, 80% of people can feel the symptoms.
Getting irritable,
yeah,
tired, listless.
Yep. But there are some people who get excited and feel elated. There are about 15% in our surveys where we went up when you had a Norwester, but the vast majority go down.
I guess it's a good thing that a Norwester generally only lasts a day or two, then it's gone through.
Yes, yeah. But on occasions they do last as long as a week. And boy, the police say they have problems. And that's because they say to us, oh, it's hot and dry, so guys drink much more. And when they drink alcohol, they become violent. They go home.
Absolutely.
And the kids are wild, the mother is irritable, and they find a problem, and so there's more domestic violence.
Compounded.
Yeah, so it's a compounding of a whole lot of effects.
So we're quite right in saying it's a strange, spooky wind.
Oh, yes, definitely.
So much for Christchurch. Here in Queenstown, the summers are hot and the winters are cold. Sunbathing in summer, skiing in winter. It's what we call continental weather, much the same as, say, Central Europe. Generally, though, New Zealand's weather is classified as oceanic temperate, tempered or modified by the sea, so it's mostly mild with long sunshine hours. But because of Queenstown's distance from the sea, it has this continental weather pattern. Another Kiwi peculiarity is windy Wellington. Question, why is it so windy here and over there in Cook Strait? Well, imagine a river held back by a huge dam. You punch a hole through the dam and the water is forced through with tremendous force. Similar in New Zealand with the Southern Alps over there and the Wellington Ranges here damming up the westerlies. The hole in the dam is Cook Strait. It's a pressure release valve, and the wind speed funneling through here is dependent upon the air pressure building up on the western side. Here in central Waikato, there's a different weather phenomenon, fog, which is basically clouds sitting right down on the ground. Now what happens is the cold, dense and heavy winter air rolls down over the wetlands and onto the river flats where there's lots of water vapour. The ground surface, which is even colder because it's lost all its heat by radiation, chills that water vapour down to its dew point and causes it to condense into tiny, windy cloud particles. Bingo, fog. But it's not all extremes. Big parts of our country have fairly constant weather. They have their own localised, packaged weather systems. We call these microclimates. Big parts of Hawke's Bay, Marlborough, Central Otago, and even here at Waiheke Island are all good examples. That's why they're suitable for producing grapes for one of our biggest export earners, wine. And in Te Puke, growing conditions are ideal for a Kiwi icon, the kiwi fruit, because the fruit loves late spring, early summer rain and winter chilling to help the bud break and, of course, the flower numbers. And there are lots of other examples right across New Zealand. Oranges and kirikiri, for instance. You see, the weather largely determines what we grow and where we grow it. However, you can cheat things a little bit by creating your own microclimate, just like these guys have done right here in Karaka, South Auckland. Not only that, the weather determines where we can keep these old beauties, because cows thrive in warm weather with good soil and reliable rainfall. Unlike the merino sheep, which don't like the ground too wet, they like the high, dry environment. Auckland, of course, has got a notorious climate with a whole cluster of microclimates. Why is that? Well, it's on such a narrow stretch of land. We call it an isthmus. On this side, we've got the Pacific Ocean, and not too far away, over here, we have the Tasman Sea. So the relative humidity is always pretty high. Plus, we get the sea breeze convergence off each of those ocean masses, where we get a lot of uplift, a cloud formation, and changeable weather. 4 seasons in one day, as many say. So we have this huge diversity in our climate, and we've adapted to it pretty well. But we still need to know what the weather's going to do tomorrow and the next day, and maybe even next week. How do we do that? With forecasting. And how does that work? Stick around.